No, no, I'm okay. The agenda. On the Dappcon website. Yeah. Cool. So welcome everyone. This is the QR code to scan to enter the Telegram group. We will have some docs link there for the tasks that we will do in the second part. So how this workshop is structured is that for the first part, we will go through some basic DeFi concepts. And for the part 2, we will actually do a couple of tasks to execute the DeFi transactions. So the vision of Enso is to be a unified network to access blockchain and DeFi protocols. We started 5 years ago, and we noticed straight away how hard it was to build on blockchain networks. It meant to integrate multiple DeFi protocols, and for every protocol you had to deploy a smart contract. Not only that, but for every single protocol lived also in different chains, so you need to take care of the deployment on the script, on the maintenance of all that part. We released the DeFi aggregator, and soon other applications started to ask us access to these protocols. So that's where the modern Enso started as an API. So developer tool where you integrate one single tool and you can access all the DeFi protocol actions and on every chain. This is our core product offering. So we have the execute part. So basically the API provides you the call data and the best route for swaps, DeFi action, which is borrowing, lending. We recently releasing, is not public yet, but is in the docs, so you can check it out. We released a flash loan aggregator, and it's basically used by lending markets to create looping positions, and the bridging aggregator. For the data part, we offer APY data, TVL data, the prices, and all of this through it's basically abstract to create a earned product. So the full suite to build your own earned product. We support basically all the DeFi protocol, I think around 100. On top of this, everything is simulated, which is, we will go through later, is quite important in a blockchain transaction that you simulate what third-party returns, because you know, like you never know what the call data does, so you need to be sure that the transaction that the user will execute does exactly what you expect. These are some numbers. We have a lot of companies using us. In the last 5 years, we've settled around 20 billions in volume, with the biggest 3-day streak that was for the Beta chain launch, Boico with layer 0 was 3.1 billions into 80 DeFi pools in the same day, 3 days. We have 13 audits, as you can imagine, was very expensive. And we have some open source tooling that it's quite cool. You can check it out in our GitHub. Temper is a transaction simulator, basically Tenderly, but open source. And the Wayroll, which is our core contract, which is a smart contract virtual machine to chain transactions. So to start, we will go through, like, how many of you know what is a DEX aggregator? Okay, I guess mostly everyone. The general idea on how it works, and then I will go through how we use it inside our DeFi toolkit, is that a DEX aggregator is basically a graph. People put all the pools, index the pools, put it into a graph, and then run pathfinder algorithms to find the best path from token A to token B. There are multiple tricks, you split them out and so forth, but this is the core concept. There is a layer on top. This is how we do for swap aggregation, which is called meta-aggregator. There are some UIs nowadays that offer this. I think the first one was DeFi Llama and OkuTrade, MetaMatcha, things like that. Our API basically meta-aggregate every single DEX aggregator, and there are a couple of reasons to do that. One, some aggregators are better than others. Some support RFQs, some support liquidity sources that others doesn't, and some are better optimized for bigger trades or small trades, and they have all different gas costs depending on the operation that they chain. This increases the execution reliability. And the most important part is that very often DEX aggregators overquote, which means that they promise you to return a certain amount, but in reality, on-chain, this is not true. And there is always some sort of delta from what is quoted versus what is executed. This is why we added a layer on top of this meta-aggregation, which is quote simulator. So we perform simulation on every response of the DEX aggregator. Then we basically sort to the real amount out, and we pick the best one that for the real amount that they return, not what they quoted. We recently released the dashboard for this. It's basically showing who are the best and who are the worst. So the overall idea is basically who simulate their transaction before returning to the users. If I put it like, wait, let me put it on Telegram. If you want to see it, it's in the Telegram group and shield.enso.build. For example, 0x is always one of the ones who simulate the transaction. We also illustrate the latency. And yeah, this is the overall. You can see sometimes quite big numbers. Sometimes we got even 100% because some DEX aggregator were putting a fee without basically saying it to the user. We generally also work with DEX aggregator. Like if we see some numbers that are too big, we try to reach out and say to check certain routes and paths. But this, I think, is an essential tool for everyone who wants to trade on chain and want to perform DeFi actions for the user, is that the aggregation part need to be correctly simulated. Otherwise, you can have a huge revert rate or basically misleading the user. If you want to check it out the website, we also have some other performance charts, the overquote rate, the simulation rate, the latency comparison, and some outliners, like in the last 7 days. This like for example, big transaction simulated was almost 1 million, and the delta is basically 51K. This is a lab test. So we basically take the call data and simulate it against the latest block, which cover most of the cases. Here you can see some other illustration for it. Why the DEX aggregator do that is a mix of reasons. Sometimes they just use a pure mathematical approach. So everything is pure computation, and they don't find the best path by simulating. Sometimes it's basically they just want more order flow. So in competition, if the meta-aggregator doesn't check this, they basically win order flow. Or and in general, they don't simulate the transaction. There is another reason that came up lately in the last months, which is like toxic pools. A lot of malicious pools came up, especially in protocols that allow to create pools with custom behaviors, like Uniswap hooks and curve pool. Basically, these pools are done in a way that tricks transaction simulator. So generally, when people do simulation, do a ETH call, and they don't set a gas price, for example, or a Coinbase account, or a timestamp, And this pool put in solidity logic certain checks that tricks the simulator and basically try to scrape as much as possible the slippage from the user. This is an example of us. Yeah.
Can you explain how they do that?
Yeah. So.
Or like one example.
Yeah. This is an example. Well, I don't have the code here, but I can show you later the code, but I can summarize it now. This is a toxic pool that was on Curve. In the last 2 weeks, basically made 120 million volume and stole 60K in fees. Generally, when you do a simulation, you do an ETH call, right? And it's like taking the call data and you say, okay, simulate the latest block, and you extract the amount out that this transaction will give to the user. The issue is that out of the box, this simulation don't consider a lot of things that are actually unset on chain, like the gas price. So some of these pools were encoding in the solidity logic. If the gas price is measured than 10, then apply a fee. So the simulator, because they don't set a gas price, was strict, and the fee was not counted in. This is a... Sorry? Is it not possible to simulate? Yeah, exactly, yeah. I mean, this is like how we kind of solve it. It's like the feature that we added lately is not only gas price, like these malicious attacks are like, they change every day. But one of the latest features that we add is toxic flow detection, which is basically we don't just simulate purely, but we start to do state overrides on the request, overwriting the block, overwriting the gas price, the Coinbase account, the timestamp. Because this was just an example, the toxic flow detection, but there are some other things like fee based on timestamp. So basically, if you make a transaction, if you get a request, you simulate it, looks good, because you simulated at this timestamp. But in the solidity logic, you can say, if 10 seconds passed, then apply a fee. So in that case, you need to kind of start to spam with simulation with different future scenarios to understand and detect if there is some sort of toxic behavior or hidden fee. Yeah, this was just an example of a pool in the last 2 weeks, but we've seen many on Uniswap hooks, and it's very hard, I have to say, for an aggregator to catch all these malicious pools, because it can really be anything encoded in Solidity. We generally report these pools to aggregator, and they are quite fast on removing it. But since we cannot trust always these responses, that's why we added base toxic flow detection and hidden fee detections. This is also one of the main features of Enso, that is a standalone tool. So you basically can call it with whatever. If you have a DEX aggregator on your app and you want to verify that the behavior is correct, you can call the Enso quarter, and it will automatically top up the balance of the user. So to simulate, you don't need that the user has the balance. It can just, we automatically top up in the simulation environment the balance of the user. You can do batch quoting and yeah, the feature that we talked about before. It's also very, very fast. So it's probably like 200 milliseconds, and you can batch simulate 10 different DEX aggregator responses, so you can pick the best one. Okay, so I think that's it for the first part. Is there any question?
These toxic pools, who's doing those? Is it like MVP kind of actors? Or?
Yeah, I mean, malicious actors. Yeah.
They call their own funds.
Yes. Yeah.
And you don't need a large capital, essentially, because you trick the oracle, either in the hooks or curve rate oracle. So yeah, it doesn't require large capital. It's just manipulating in a sense that oracle returns higher price than market average. DEX aggregators choose that pool, and then during execution you get caught.
Right. And do you have approximate numbers, like over months,
No, not yet. I mean, it's something that I wanted to look into, especially because lately the number of toxic pool increased a lot. We started to see a lot of failed transaction on all the meta-aggregators. And it was mainly what we seen was Uniswap hooks and curve pools. It will be nice to run some analytics on this. Yeah. I think we will something that we will do in the future. Cool. So the second part, it's more hands-on, and it's about building a earn product. It will use the Enso API to create the basis, so getting the user balance, the data, so of the DeFi position, so APY and TVL, the route actions, so you can do swaps and DeFi deposit and a single chain on different chains. Access RWA. We are minter for Xtox and Ondo, and soon a couple of other RWA providers, and in general DeFi actions. Sorry, we started 15 minutes ago because there was a time change. So in general, there are two different types of DeFi positions. The simple one are tokenized DeFi positions, which means what probably protocols that you know already, like Aave, Pendle, everything that gives you a ERC20 receipt. And this is it's all available in the route endpoint, because this being a tokenized position, you can use routing, which means DEX aggregator plus a DeFi hook to enter a specific position. There are some other more advanced type of positions which are non-tokenized, which means opening a borrowing position, open an NFT position, deposit without any ERC20 receipt, a sync vault, for example, like vaults that either don't allow everyone to deposit, so that you kind of make the request, and then in a second moment they will send you the ERC20. For example, Open Call, it's a insurance wrapper for vaults. In that case, you request a deposit, you stake your request, and they will send it to you. And all these actions are composable with the bundle endpoint. So, since few people joined, I think the time on the agenda was wrong. We started 15 minutes ago. If you want to join now that we will do the task, this is the Telegram group. Okay, this is the first task. It's pretty simple. Just get used to the API. In the Telegram group, there are the docs links, and it's basically to create a simple DeFi route Ethereum into a lending pool, in this case Aave. I think we will leave like 5-10 minutes for you to play around, and then we will show it into the screen here. Is there any question?
Can you give us a QR code again?
Yeah. Can you see the messages on Telegram?
No.
Oh, okay.
No, it's here. Thanks.
And I will link the dashboard that we talked about in the first section on comparing DEX Aggregator For the people who join now, just to give a quick recap, we went through how a DEX aggregator work, why you need meta-aggregation, which is basically you cannot trust DEX aggregator and you need to simulate what actually they return, what they actually return. For a various reason, can be like just miscalculation or they want to get more order flow. We release a dashboard that is testing all the DEX aggregators that is linked in the Telegram chat. And we also talked about toxic pool that a lot of these DEX aggregators are vulnerable to, which means pools that try to fix with solidity logic simulations. And yeah, this is an example of the last 2 weeks. A pool stole 60K in fees from DEX aggregator routes. And because of this, it's not announced yet, but we released it since a week. We added toxic flow detection. So when you simulate with our simulator, you get the actual return that is already counting in the toxic pools fees. I will go back to the task. And if something is not working, just call us and we will come there to check. I posted in the chat in the Telegram group the endpoint for that request, and now we'll add the token address in case you didn't find it.
I'll put it in.
Sorry?
I'll put it in.
Okay. Okay, I think we can move on. Brandon will show now basically the task from a terminal, just to inspect the response, and we can see how the first part, the meta-aggregation, is used with the Aave DeFi hook.
Yeah. And should I use the mic? Yes. Yeah. Okay. So what do you see on the screen is essentially the request for...
Sorry, can you zoom a bit? Maybe, I don't know if the
sorry.
streaming, yeah. Okay, perfect.
Sounds right, yeah. Yeah, essentially the request to route from Ether to Aave's AUSDT on Aave v3. I can just simply go through each line, amount in, which is in wave value, which is 1 Ether in this case. Token in, we represent it as the quote-unquote native address. Token out is the AUSDT. Slippage can be set, cannot be set. Default is 50 that we always set for every route. From address is the address who is going to execute the route. Receiver is also optional. You can specify if receiver. If you want the funds to land in a different address, usually it's never the case. It's always the same address. Chain ID 1, which is the mainnet, and then I'm passing the API key. And then, yeah, this is the response, which returns the call data together with gas, amount out, the price impact of the route, just to ensure that unexpectedly the value that you receive is not significantly less than you inputted. And the whole transaction object that user executes. And then the interesting part is the route, where essentially you can see two different hops. The first one is the swap from Ether to the underlying of USDT, which is USDT, which is the USDT. And then we take the whole amount that was produced by the swap and put it into an Aave USDT. That's it.
Yeah, so the first part is basically what we've seen before with the meta-aggregation. In this case, a northern one. The transaction was simulated, and then there is this DeFi hook. You can go. The DeFi hook, which basically is saying, take the amount out that was returned from the swap action, and basically deposit into the Aave lending market.
Yeah, and if you're interested, that's the Enso Simulator that Milos previously mentioned, which is open sourced. You can check it out on our GitHub.
The call data you can of course like double verify if what we return is correct. A lot of people like to use Tenderly for having the full UI to simulate. Our type of simulation is a bit different. It's more like very specific and meant to be very fast. But for like inspection of the full route as code, I can recommend Tenderly UI. Okay, is there any question on this part? If not, I will move to the second task. I'm assuming everyone will use Cloud Code, so it's more like a prompt that rather than a task. Yeah. Okay. So the task 2 is more like to show the end-to-end of an earned product, how it could look like. We have multiple endpoints for this. I linked it in the Telegram group, which is this one. So basically, the task is to create a small UI where the user can connect with MetaMask or Rabbi. You can use the balance endpoint to show the user balances, which it's already organized by DeFi protocols. So you can see, like, when you get to the endpoint we will leave 5-10 minutes for the task for you to play around. Then we will show it on the screen. It basically organizes everything by DeFi protocol. So if you have an Aave position or you have a Pendle position, you will see it there. The second part of the task is to display basically a box where you can show the APY and TVL of the DeFi position. And the third one is to actually use the one that we used before, so the route, to allow the user that is connected to actually execute this transaction. If you want to test on a cheaper network, we support Aave on every network, so you can just pick Base instead of Ethereum. Yeah, that's it. I will leave 5-10 minutes, and then we will go through again with code and some UI example here. And again, if you have any question, you can just reach out. Yeah, is the protocols endpoint. Maybe I can show you. Yeah, we have a Swagger is linked into the Telegram chat. So we have a bunch of protocols. Maybe meanwhile I can go through. Sorry, a bunch of routes, endpoints. The basic one is the route, the part that I mentioned before about simple tokenized positions like RC20. The non-tokenized route, which means NFTs and all the sort of position that don't return a receipt token. The bundle endpoint, sorry?
No, I wanted to say best example would be Morpho in that case, for non-tokenized.
Yeah, definitely. And the bundle endpoint, this is meant to use declarative DeFi actions. So swap plus deposit plus borrow. If you want to do it in a certain way or orchestrate your own flow, you will use this endpoint. Going back to the question, there are like all the metadata endpoints. So the network that are supported, the prices, the tokens, the non-tokenized positions, and the protocols. So you can see for chain ID 1, I think you should return all the list of protocols that we return. Yeah. Xtox, and also the chain where these protocols live. So Xtox, Yearn, Orderly, Pendle. There are quite a lot. I mean, it's like most of them now they have 0 TVL, but are still supported. Yeah. Yeah. Both for swaps. And I think also to deposit into the LP pools. Do we have deposit into? Yeah, we have our own DEX aggregator, but generally the swap part is managed by the routing.
Yeah, in the Fluid we don't have the LPs, we have the deposits in for the lending part.
No, we do have looping. Yeah,
Looping as well,
Fluid,
yeah.
yeah. No, we don't have the LP tokens of the DEX. but we have the lending market.
Just deposit.
Yeah. The looping, you can achieve it by doing a flash loan into another protocol, like Morpho. Yeah, we have also a bunch of other endpoints, but these are for the cross-chain part. So to track the transaction with relay, layer 0, CCIP, CCTP.
Also, if you're in the Telegram group, I put the link. How would you get all the fluid lending receipt tokens, essentially, where you can route? I put it in the Telegram group.
Yeah.
The link where you could see a list of all the assets that you can route into that are related to fluid lending.
I can't open it. You exceeded the request limit.
Did you show it?
Also, API.enso.finance doesn't work. I get like an error.
Is a .build. Wait. Here you can create the API key. It generally works also without API key, but yeah, of course there are like limits for that. You can also use this one, it's disposable. Okay, do you want to show how it works for these endpoints?
Yeah.
Oh, sorry.
Remind me,
This one. I think you need to press somewhere. Yeah.
Yeah, so what I'm showing is an endpoint that you can use to fetch user balances or any other balance. And it will return you a list of the balance on the same chain, on the chain that you specified, sorry. And then you can find if user has DeFi tokens, you can then fetch the tokens endpoint. This endpoint can be used to fetch the metadata of the tokens that we support, that can be routed to, which essentially should also include the Aave USDT one that I showed before. The metadata, if a token is a yield-earning asset, you'll have additional data like APY, TVL, that you can use to display to the user, help them understand what is the state of the asset. And you will see that, yeah, currently I'm just fetching the Aave v3 assets. That is like a type DeFi. That's how we identify assets that are require special actions. In this case, it will be a deposit into Aave v3. The other type we have is base, which we just do a simple swap into via DEX aggregators. Is there anything else I missed?
No, that's fine. Let me plug it. Yeah, I can show here the a more visual example. So this is basically doing the same thing that the task 2 was doing. Basically, you can get the protocol list. These are all the protocols supported on Ethereum. Spectra, Pendle, Aave, and so forth. We can check Aave, and we can select Aave v3. So 2% APY, 700 million TVL, and we can see the visual part, which was like the same of the terminal. There is a swap and the DeFi hook into the Aave v3 pool. Cool. Is there any question for the last part? Okay, so to conclude, these were basically mostly the, sorry, it's lagging a bit the computer. I think. Oops. It's really stuck. So. It's really stuck, so okay. Let me see. Sorry, there is quite some delay, I think, because I connected the, I need to buy a new Mac. Okay, yeah. So all of this was the first, the simple part, which was the tokenized position, so the simple DeFi tokens, the receipt. For the more complex part, you will need to use the bundle endpoint or the non-tokenized endpoint. I'm trying to get to the right slide. Okay. Hopefully it stays like this. Okay. For the advanced use cases, generally we do support it into the non-tokenized endpoint, where you can pass a position ID that represent the NFT, for example, or other abstracted parts. Otherwise, we have the bundle endpoint where you can be more declarative. So you can say, first do a cross-chain transaction, and in the callback of the cross-chain transaction, you swap and deposit into a token. Or certain stablecoin uses this endpoint for abstracting the chain. They usually have a minting contract on Ethereum, and they want to have the user just to, come from the whatever chain, click deposit, and receive on a certain chain. So what we do in this case with the bundle endpoint, you can construct the route saying, I will bridge the stablecoin, the USDC, for example, mint the stablecoin, and then in the same transaction, send back to the original chain the stablecoin. This is because stablecoin issuer often prefers to have the liquidity and the minting system on a specific chain, but still want to be composable with the DeFi protocol on, for example, Optimism on Hyper EVM. So in this, using the bundle endpoint, you can construct a more complex iteration and basically create abstraction. We will release probably next week sorry, you want to say something?
I just wanted to add to the bundle endpoint. It's a place where you can express yourself in a low-level way, even if we don't have any some actions from some sort of protocols. You can do low-level calls to the contracts that you wish to combine them, take the outputs from those low-level calls to other inputs. It's a great tool if you want to express yourself in a certain way for a specific route that may require more logic than just a simple token A, token B. And yeah, as Miloš mentioned, that one of the principles is the double bridging, how I call it, and the other one that recently came quite common is the flash loan looping.
Yeah, and the bundle endpoint, I'm trying to, the computer restarted. The bundle endpoint, it's having the same security measures as the other endpoints. So basically all the transaction simulator and the outcomes are used to write on chain the minimum amounts. So you don't risk that your transaction get front run or MIV attacks. And of course, there is also all the simulation part of to skip toxic pool or fake quotes from DEX aggregators. Yeah, I think that's it. Do you have any question? Cool. So thanks everyone for joining.